Have you ever gazed up at the night sky and wondered if we are alone in the universe? It's a question that has captivated our collective consciousness for millennia, a question that is as profound as it is perplexing. The search for life beyond our home planet is more than just a scientific endeavor. It's a quest that touches on our deepest philosophical and existential musings about our place in the cosmos. Consider this. If we were to discover a microbe on Mars, a tiny, single-celled organism eking out a living in the harsh Martian environment, it would fundamentally change our understanding of life itself. It would tell us that life is not unique to Earth, that perhaps, just perhaps, we are not alone in the universe. But what if the opposite is true? What if Earth, with its life-sustaining conditions, is a cosmic anomaly, a rare jewel in the vast expanse of the universe? This is the crux of the rare Earth hypothesis, coined by geologist Peter Ward and astronomer Robert Brownlee. The rare Earth hypothesis posits that Earth's life-sustaining conditions are not just rare, but exceptionally so. This hypothesis hinges on a series of finely balanced and unusual conditions that came together on Earth, creating a perfect environment for life to flourish. From our planet's robust magnetosphere shielding us from solar radiation, to the presence of plate tectonics recycling essential elements, to our large moon stabilizing Earth's axial tilt, and our location in the galaxy protecting us from cosmic catastrophes. These are just a few of the factors that, according to proponents of the rare Earth hypothesis, make our planet uniquely suited for life. While this theory is not without its critics, it provides a fascinating lens through which to explore the question, are we alone in the universe? So, as we embark on this cosmic journey, let's keep an open mind and a sense of curiosity. For it's in the spirit of exploration and discovery that we continue to push the boundaries of our understanding. So, let's dive into the cosmic ocean and explore the possibility of life beyond our home planet. Life on Earth began almost as soon as it possibly could. Fascinating, isn't it? Our pale blue dot, our home, didn't waste any time at all. Just a few 100 million years after it formed, life emerged. And it wasn't just simple life forms. No, it was complex cellular life capable of reproduction and evolution. This quick start of life on Earth is not only intriguing, but also raises some crucial questions about life in the universe. To understand the significance of this early emergence, we need to consider the concept of the cosmic calendar. In this calendar, the history of the universe is compressed into a single year. On this scale, the Earth forms on September 1st, and life appears by September 21st. That's quite a quick turnaround. This quick appearance of life on Earth suggests that, given the right conditions, life could pop up relatively quickly. And if life emerged so rapidly here, could it not have done so elsewhere too? This leads us to the exciting possibility that life could be common in the universe. But there's a catch. You see, our understanding of life's emergence is based solely on Earth, a single data point. As any statistician would tell you, drawing conclusions from a single data point is risky. We can't be sure if Earth's experience is typical or a fluke, and that's the limitation of using Earth as our only reference. So, while the early appearance of life on Earth suggests that life may be common, we have to entertain the possibility that it could also be rare. The universe is a vast place with countless stars and planets. Life could have started in countless ways, in countless places, and we're just beginning to scratch the surface of understanding it. But what if Earth isn't the rule, but the exception? That's the question we must ponder as we continue our exploration of the cosmos. The answer could redefine our understanding of life, the universe, and our place within it. Enter the rare Earth hypothesis, a theory that suggests our planet is not just rare, but unique. This hypothesis, proposed by Peter Ward and Robert Brownlee, posits that the conditions necessary for complex life are so finely balanced and unusual that they are unlikely to occur elsewhere in the universe. The rare Earth hypothesis is not a statement about the lack of extraterrestrial life per se, but rather it's a theory about the scarcity of complex life forms like us. It suggests that while microbial life may be common, the evolution to complex organisms is an extraordinarily rare event, limited to a tiny fraction of habitable planets. So, what are these unique conditions that make Earth so special? Let's delve into the 4 key factors often invoked by proponents of the rare Earth hypothesis. Firstly, there's our planet's magnetosphere. This invisible magnetic field, generated by the churning of our planet's molten iron core, acts as a protective shield against harmful cosmic radiation and solar winds. Without it, the atmosphere and the life it sustains would be slowly stripped away. Secondly, we have plate tectonics, a geological phenomenon unique to Earth amongst the planets in our solar system. Plate tectonics play a vital role in maintaining a stable climate over geological timescales, recycling carbon and other elements between the Earth's surface and its interior. This process, known as the carbon-silicate cycle, acts as a global thermostat and is crucial for long-term habitability. The third factor is our large moon, which stabilizes Earth's axial tilt, preventing drastic climatic shifts. The moon's gravitational pull results in tides, which in turn have played a significant role in the evolution of life on our planet. Lastly, our planet's location in the solar system provides protection from impacts. Jupiter, our giant neighbor, acts as a kind of cosmic vacuum cleaner, its massive gravity attracting and capturing most of the asteroids and comets that cross its path, sparing Earth from frequent catastrophic impacts. Now, it's important to note that these factors and their relevance to life are subjects of ongoing scientific debate. For example, Mars also has evidence of past tectonic activity, and Venus, despite lacking a magnetosphere, has a thick atmosphere. The idea is not that these factors are essential for life to arise, but that they have made it possible for complex life to persist on Earth for billions of years. In essence, the rare Earth hypothesis suggests that it's not just about having the right conditions for life to begin, but also about maintaining those conditions for long enough for complex life to evolve. It's about the stability and longevity of these favorable conditions. It's also worth mentioning that the rare Earth hypothesis does not rule out the possibility of finding simple life forms elsewhere in the universe. In fact, it fully acknowledges the potential for life to exist in places like the icy moons of Jupiter and Saturn, or even beneath the surface of Mars. But it maintains that the evolution from simple to complex life is a leap that may not be easily replicated elsewhere. The rare Earth hypothesis is, in many ways, a cautionary tale about taking our existence for granted. It underlines the incredible confluence of circumstances that have allowed complex life to flourish on this small blue planet in the vastness of the cosmos. And it reminds us that we are, indeed, extraordinarily lucky to be here. So, how do we calculate the number of Earth-like planets in our vast galaxy? Well, that's a question for the next scene, as we delve into the intriguing world of the rare Earth equation. Stay tuned. The rare Earth equation is our mathematical tool to estimate the number of Earth-like planets. This equation, in its essence, is a method to calculate the odds of life existing elsewhere in the universe. However, before we dive into the math, let's remember that the rare Earth hypothesis suggests that the emergence of complex life requires a host of very specific and unlikely conditions. Now, the rare Earth equation includes a number of factors that, when multiplied together, give us an estimate of the number of planets in our galaxy that could potentially host life as we know it. These factors range from the frequency of stars with planetary systems, to the number of planets in the habitable zone of their stars, to the likelihood of life developing on such a planet, and even the odds of that life evolving into intelligent beings. The more factors we include in the equation, the more specific we can get with our predictions. But also the more the estimated number of potential Earth-like planets dwindles. For instance, if we only consider the number of stars with planets in the habitable zone, we might arrive at a quite optimistic number. But when we start adding conditions such as a stable orbit, a suitable atmosphere, the presence of water, or a protective magnetosphere, the number of potential Earth twins starts to shrink dramatically. It's like trying to win a cosmic lottery. The more conditions we add to our winning ticket, the less likely we are to find a match. And here's the interesting part. Even with all those conditions, the equation doesn't necessarily hit zero. There's still a chance, however small, that somewhere out there in the vastness of space, there's a planet that has hit the jackpot just like Earth did. However, it's important to note that the rare Earth equation, like any scientific tool, is only as good as the data we feed into it. And with our current knowledge and technology, many of these factors are still based on educated guesses and assumptions. That's why scientists are constantly refining and updating the equation as we learn more about our universe. There's also the question of what we consider Earth-like. Is it enough for a planet to be in the habitable zone of its star? Or does it need to have an Earth-like atmosphere, oceans and continents, or even a similar evolutionary history? The answers to these questions can drastically change our estimate of the number of Earth-like planets. In conclusion, the rare Earth equation provides a framework to explore the possibility of extraterrestrial life. It's a tool that helps us understand the immense odds we overcame to exist and gives us a sense of how truly rare and precious Earth might be in the grand scheme of the universe. But what about the planets we've already discovered outside our solar system? That's a question for the next part of our journey through the rare Earth hypothesis. Let's move on and take a closer look at these fascinating worlds known as exoplanets. The past few decades have seen an explosion in the discovery of exoplanets. Let's take a moment to appreciate the magnitude of this statement. The universe, once thought to be largely empty, is now known to be filled with countless planets orbiting stars beyond our solar system. These so-called exoplanets are the new frontiers of space exploration and the search for extraterrestrial life. Exoplanets come in all shapes and sizes, from gas giants larger than Jupiter to rocky bodies smaller than Earth. They orbit their host stars in a variety of ways, with some taking mere days to complete a circuit and others requiring hundreds of Earth years. The diversity is astounding and provides a fascinating insight into the myriad ways planetary systems can form and evolve. But not all exoplanets are created equal, especially when it comes to the rare Earth hypothesis. This theory posits that Earth-like planets, those with conditions suitable for the development of complex life, are exceedingly rare in the universe. Therefore, when we speak of exoplanets in this context, we're particularly interested in those which resemble our homely rock. Take, for instance, the exoplanet Kepler-22b. Discovered by NASA's Kepler Space Telescope, this planet orbits within the habitable zone of its star, where conditions could potentially allow for the existence of liquid water. However, while Kepler-22b might exist in the so-called Goldilocks zone, it's considerably larger than Earth, leading scientists to speculate that it may be more akin to a mini Neptune than a second Earth. Then there's Proxima Centauri b, the closest known exoplanet to our solar system. It orbits in the habitable zone of Proxima Centauri, the nearest star to the Sun. Despite the relative proximity, Proxima Centauri b is not without its challenges. The planet is subject to stellar winds far stronger than those experienced by Earth, which could strip away any atmosphere and make the surface inhospitable to life as we know it. These examples highlight the difficulties in finding truly Earth-like exoplanets. Yes, we've discovered thousands of planets out there, but how many of them could support life? This question drives the ongoing and future efforts to detect signs of life beyond Earth. One of the most exciting developments in this field is the launch of the James Webb Space Telescope. This marvel of technology will peer into the cosmos with unprecedented clarity, investigating the atmospheres of exoplanets to search for chemical signatures indicative of life. In addition to the James Webb Space Telescope, there are numerous other projects and missions dedicated to the search for extraterrestrial life, from ground-based observatories scanning the skies for telltale signs of biological activity to ambitious proposals for interstellar spacecraft. The quest to answer the question, "Are we alone?" is more vibrant and diverse than ever before. These efforts represent the cutting edge of science and technology, but they're also a testament to human curiosity and determination. We look up at the stars and wonder, is there anyone else out there? It's a question that's been asked by countless generations before us, and will likely be asked by many more to come. The rare Earth hypothesis provides a framework for this inquiry, suggesting that the conditions on Earth are not just conducive to life, but incredibly unique. If this is true, then the universe might be a lonelier place than we'd like to think. Yet it's essential to remember that the rare Earth hypothesis is just that, a hypothesis. It's a compelling idea, underpinned by a wealth of scientific understanding, but it's not a definitive answer. The universe is vast and varied, and we are but beginners in the grand journey of cosmic exploration. Our search for Earth-like worlds and the life they may harbor is the embodiment of this journey. As we gaze upon the expanse of the cosmos, we do so with a sense of hope and a thirst for knowledge. For even in the vastness of space, we seek connection and kinship. We seek to understand our place in the grand tapestry of existence. However, the rare Earth hypothesis isn't without its critics. Some critics argue that the rare Earth hypothesis suffers from a strong anthropocentric bias. This criticism is rooted in the belief that the hypothesis assumes the Earth's path to life is the only way, the single correct formula for the emergence of life. This assumption can be seen as human-centric or anthropocentric because it's based on the only example of life we know, us. This perspective, however, may limit our understanding of the universe and the potential for life beyond Earth. Why? Because it assumes that life elsewhere must follow the same recipe that happened here on Earth. But what if life in the universe is more flexible, more adaptable than we give it credit for? What if there are multiple pathways to the emergence of intelligent life? Consider this: the Earth's conditions are indeed unique in many ways. The presence of a large moon, a strong magnetosphere, plate tectonics, and protection from cosmic impacts are all factors that have undoubtedly contributed to the flourishing of life on our planet. But are these conditions absolutely necessary for life to exist? Or could life, given enough time, adapt and thrive under different circumstances? This is where the anthropocentric bias of the rare Earth hypothesis comes into play. By assuming that life requires the same conditions that we have on Earth, we might be overlooking planets that could house life forms that are vastly different from anything we can currently comprehend. A more comprehensive approach to understanding life's potential in the universe could be to consider parallel paths to life. These parallel paths might not require the same conditions we have on Earth, but could still lead to the emergence of life. For example, life might exist in the subsurface oceans of icy moons like Europa or Enceladus, where conditions are vastly different from Earth. The assumption of a single path to life also impacts the rare Earth equation, which calculates the number of Earth-like planets in the galaxy. This equation, as currently formulated, doesn't account for these potential parallel paths to life. A modification of this equation to include other potential pathways could give us a more accurate estimate of the likelihood of life elsewhere in the universe. However, it's essential to recognize that this is a complex topic with many unknowns. The science of astrobiology, the study of life in the universe, is still in its infancy. Our understanding of what constitutes a habitable environment and how life emerges and evolves is continually evolving. As we continue to explore and learn more about the universe, our perspectives on these issues are likely to change. In conclusion, while the rare Earth hypothesis provides a compelling argument for why we may be alone in the universe, it's crucial to be aware of its limitations. The hypothesis's anthropocentric bias could potentially limit our understanding of life's possibilities in the universe. By considering multiple pathways to life, we may broaden our search for extraterrestrial life and increase our chances of finding it. This is not to say that the rare Earth hypothesis is without merit. On the contrary, it helps us appreciate the unique conditions that have allowed life to thrive on Earth. However, it should not limit our imagination and curiosity in the search for life elsewhere in the cosmos. After all, the universe is a vast place, and we are just beginning to explore its wonders. The discovery of life elsewhere would have profound philosophical and societal implications. These implications, which we will delve into in the next section, underscore the importance of continuing our search for life beyond Earth. The quest to understand our place in the universe is one of the most profound questions of human existence, and one that we are privileged to explore. Imagine the day we discover life on another planet or moon in our solar system. Such a discovery would not only be monumental in the scientific community, but it would also have profound philosophical and societal implications. The rare Earth hypothesis, which posits that the conditions on Earth are so uniquely and finely balanced that they may be exceptionally rare in the universe, has far-reaching implications for our understanding of our place in the cosmos. If the hypothesis holds true, it might mean that we are indeed alone, or at least very isolated in this vast universe. This thought could be both humbling and daunting, emphasizing our responsibility to preserve our planet and our species. On the other hand, if the hypothesis is proven incorrect and life is discovered elsewhere, even in the simplest microbial form, it could fundamentally change how we perceive ourselves. No longer would we be the sole bearers of life's torch in the universe. We would be part of a larger cosmic community, a thought that could promote unity among humankind, as we realize that we are all citizens of the universe. The implications of the rare Earth hypothesis extend to our societal structures and religious beliefs as well. Many religions, for instance, are centered around the belief that human life is unique and divinely created. The discovery of extraterrestrial life could challenge these beliefs, prompting profound philosophical and theological debates. It could also spur a renewed interest in space exploration and the scientific pursuit of understanding our universe. The prospect of not being alone in the universe could motivate us to reach further into the cosmos, to seek out our cosmic neighbors and to learn from them. However, it's crucial to remember that these are just possibilities. We must remain open-minded and agnostic until evidence is presented. The rare Earth hypothesis, like any scientific theory, is subject to revision and refinement as our understanding of the universe expands. In the end, whether we are alone or not, the exploration of this hypothesis reminds us of the grandeur of the universe and our small yet significant place within it. It prompts us to ponder the marvels of existence, to value the life we have, and to strive for a deeper understanding of the cosmos. Now, we'd love to hear your thoughts on this cosmic conundrum. What do you think about the possibility of life beyond Earth? A question that has intrigued humanity for centuries. Would life on other planets look like us? Or would it be so alien and complex that our minds can't even begin to comprehend it? Is the rare Earth hypothesis a beacon of truth in our quest to understand our place in the universe? Or is it a limitation, a narrow lens through which we view the cosmos? We've journeyed together through the cosmos today, from the birth of life on our blue planet to the farthest reaches of the universe. We've pondered the potential for life beyond Earth and the implications of the rare Earth hypothesis. But what are your thoughts, your perspectives, your theories? We encourage you to share your thoughts in the comments section, engage in the discussion, add to the collective pool of knowledge and ideas. Remember, the journey of exploration is far from over. In our quest to answer the question, are we alone in the universe? We've journeyed from Earth to the edges of our galaxy. We've delved into the mystery of life's quick start on our home planet and pondered the implications of using this single data point to gauge the possibility of life elsewhere. We've explored the rare Earth hypothesis, a theory proposed by Peter Ward and Robert Brownlee that suggests life in the universe is not a common phenomenon, but a rare and precious occurrence. The hypothesis hinges on the unique and finely balanced conditions on Earth, including our planet's magnetosphere, plate tectonics, large moon, and protection from impacts. These factors, while essential for life as we know it, are not universally present on all planets, potentially limiting the spread of life in the cosmos. We've also delved into the rare Earth equation, a mathematical model used to estimate the number of Earth-like planets in our galaxy. This equation takes into account a multitude of factors, each one further narrowing down the odds of finding another planet that hosts life. Yet, our journey didn't end there. We've ventured beyond our solar system to the realm of exoplanets, distant worlds orbiting stars other than our Sun. We've learned about their discovery, their diverse characteristics, and how they tie into the rare Earth hypothesis. We also highlighted ongoing and future research efforts, like the James Webb Space Telescope, dedicated to detecting signs of life beyond Earth. But we also acknowledged the limitations of the rare Earth hypothesis, recognizing the potential anthropocentric bias in assuming that Earth's path to life is the only way. We considered the possibility of multiple pathways to the emergence of intelligent life, reminding ourselves that the universe is vast and diverse, and its secrets are yet to be fully unveiled. We've contemplated the philosophical and societal implications of discovering life on other planets or moons in our solar system. We've questioned humanity's place in the universe and stressed the importance of remaining open-minded and agnostic until concrete evidence is presented. In this journey, we've not only learned about the scientific theories and debates surrounding the search for extraterrestrial life, but we've also invited you to participate in the discussion, to share your thoughts and perspectives, to engage with this fascinating topic that touches on our deepest existential questions. But our journey doesn't end here. The search for life beyond Earth continues, its significance echoing through the corridors of science, philosophy, and culture. Every new discovery brings us closer to answering the question, are we alone in the universe? Yet, every answer breeds new questions, fueling our curiosity and propelling us forward in our quest for understanding. As we continue to explore the cosmos, let's remember to approach this question with an open mind, free of preconceptions. Because the universe, in all its vastness and complexity, is full of surprises. And so we invite you to join us on this ongoing journey. Share your thoughts, ask questions, and be part of this grand exploration. If you've enjoyed this journey, don't forget to like and subscribe to stay updated with our latest adventures into the cosmos. Until next time, keep looking up and let your curiosity guide you.